So here is a beautiful blog by one of my favorite statisticians, Jim Frost. His writing is really elegant, simple, and he keeps everything very interesting here. So do check this out. And we're talking about hypothesis test. So first thing to understand about hypothesis testing is it's a part of inferential statistics and not descriptive statistic, implying that in an inferential statistic, you try to make conclusions about or inferences about population based on a little bit of data, which we call sample data, that's drawn out of the population and assumed to represent the bigger population, right? So in a hypothesis test, we are kind of examining two opposite statements, two mutually exclusive statements. So let's say if one statement says it's true, then the other has to say it's false, right? And we are trying to evaluate which one of it is true, right? So by default, the null hypothesis statement is taken by default to be true, and the alternate hypothesis is something we have to gather evidence for from the sample data. All right, the sample data should provide you evidence, as in there are lots of hypothesis tests, for example t-test and ANOVA, and there are many more. So those tests will try and find out if there is enough evidence in the sample for you to say that the alternate hypothesis statement is true, and we can reject the null, you see. Otherwise, by default, null hypothesis is true. So the point of conducting a hypothesis test is always to come to a conclusion whether do we have enough evidence in the data, in the sample data, to say that we can reject the null and we can accept the alternate. Of course, hypothesis tests are not 100% accurate because the evidence that you are gathering is based on the sample that is drawn, and sample never ever represent 100% accurately. The sample cannot 100% accurately represent the population because it's a sample, and there is always some sampling error, as in if you draw a sample and if I draw a sample, our methods could be different, or the randomization that we do, like if you're going to employ randomly picking some 10% of the population, let's say, then your 10% and my 10% would be different. Hence the sample will always vary a bit, right? And there will always be different conclusions based on the sample. So our hypothesis test is basically dependent on the sample that we have, and it's never ever going to be 100% accurate because they use a random sample to draw conclusions, right? And having said that, let's take a look at a couple of hypothesis tests the next time. Thank you.